I would like to introduce Shannon Wyrick, presenting on the edge of small data. Shannon is a VP research at NS1 and traveled from New York to join us on stage. This is Shannon's first time presenting at NANOG, and it's a pleasure to have him speaking with us today. Welcome, Shannon.
Everybody, thanks for having me here. Thank you, NANOG, for hosting. And thank you all for holding your attention to the last talk of the day. Let's jump in. I'm going to start with a quick poll of the audience as well. So who here is currently processing visibility data, some kind of telemetry from their infrastructure? Hands go up. Good. Awesome. Quick follow-up question. Who thinks they could be getting more out of that solution? In other words, who's not quite happy with it? Who thinks we could do better? A couple of hands. Okay, that's great context. So I'm going to talk about this concept I've been thinking about called small data and see if it sits with you folks. So I'm going to come about it from the angle of the company I've worked for many years, so NS1. And we, among other things, do managed authoritative DNS. We have a global Anycast network that serves DNS queries for our customers. We're doing something in the order of 100 billion DNS queries a day on a good day, on an attack day, maybe that's higher. And of course, we are collecting telemetry from our systems. So we're looking at flow data. We're pulling it into systems. We're processing it. We are also looking at the packets themselves and extracting information. And I would say that the way we've thought about how to do that over time has changed. And you know, maybe some of you will associate with this, but early on, we thought, what data should we collect? Well, let's collect all of it, right? That gives us the ability to ask any questions we want. We're not quite sure what we want from the data yet, so let's just stuff it all somewhere, and then we'll figure out what to do with it. And over time, I think what we've learned is that that's not actually what we want, or at least that there are other strategies to think about. And what we actually want are targeted insights, the things that help us today to operate and debug and scale, protect our network. And I would argue that there's a price to pay for streaming raw data to some kind of central solution, and that there is another way to think about it. Some of the lessons that we've learned over time just by dealing with trying to push a lot of data around. So often there's complicated data pipelines. You have to find ways to collect it all, to ship it around. It's often a patchwork of different tools. And then you have to do something with it, right? So the raw data isn't particularly useful. You have to process it in some way. There's costs associated with that, both time and money. And then you have to start to make sense of the data, right? Sometimes that's hard. You're not even sure what the data is telling you. You have to be able to extract the insights you're looking for, and so you wind up having a lot of data that you're not even sure you're getting all the value out of. And in the past, we've also seen, these types of solutions can lead to slow dashboards and the short retention times because we can't store that much. And in times of problems, if you're under some kind of attack or something, it can take time to get that information through your system so that you can visualize it and understand what's going on. And ideally, you want that information directly at the edge, directly close to where the events are happening. So I've been thinking about this different way to do it. So I'd like to propose this idea of small data. And what I mean by that is to think about pushing that processing that we do after collecting all of that raw data, push that out to the edge. And be able to look at the data in real time that's coming into our edges, right? We know that there's a lot of interesting information in there that we want operationally, but let's push that analysis out there and extract those insights that we're looking for in real time at the edge. And if we think about doing it that way, there are several benefits, right? So one is we can react quicker because we have those insights available local to the nodes where the source of the events are happening. And so we can potentially action on that information immediately, faster. But we can also collect that centrally, right? So we do have the global view of what's going on across our infrastructure, across our topology. And in general, if we do it that way, we have less data to deal with, right? We're collecting less data. We are processing less data, we're storing less data. And one of the ways, I've talked about this is that rather than thinking about collecting a bunch of data and then later on, theoretically, we'll find the needle in the haystack when we're ready for it, let's just collect the needles. Let's just collect the insights we're looking for that help us operate today. And part of that proposal is that we want to decide what those needles are. We want to decide what the insights we're looking for are in real time. And so we need this dynamic ability to tell our observing tool at the edge what we're interested in. So my name is Shannon Weyrich. I've been in the internet infrastructure industry for quite some time. I spent the last 8 years at NS1, and the last year and a half or so working on the Orb project that I'm going to talk about at NS1 Labs. This is my email address. I'd love to hear from anyone who's got thoughts on anything I'm talking about. So I'm going to give a quick TLDR also. I know it is the last talk of the day. I know we've got an event right after this, so if anybody kind of wants to hear the quick summary in a few slides and then slip out, I have no problem with that. Orb is an open source edge observability platform. So it's a tool that we've been working on that's designed for distributed edge networks. It uses this small data paradigm that I've mentioned, and it combines that with this idea of dynamic policy orchestration, that we can reprogram our fleet of observers in real time. And the goal is to extract insights at the edge from all this data that's flowing through and pull it into our observability stacks. So we want to integrate with modern observability stacks. And everything I'm going to talk about is free and open source. This is a dashboard, right? Just to kind of cut to the chase a bit, here's an example of something you can put together with the output of this Orb system. This is a community dashboard we have on Grafana. And right away, we can start to see some of the information that we're talking about when we say we want to extract some things at the edge. And the idea is that we can do some deeper streaming analysis at the edge using data sketch algorithms that can examine and summarize the data in ways that we care about. And a lot of that are things like TOPS, right? We care about various layers of the network packet that we see. We care about top IPs and top ASNs, top MAC. And we also want to go a level deeper sometimes. Certainly the background of this project is coming out of a DNS provider, and so we have very good DNS support. And to operate our networks, we care about top queue names, top R codes, top queue types, and things like that you would expect. And then on the networking side, digging into the flow data and being able to pull out interesting information as well. So this is the system that I'm going to talk about. And since we don't have too much time, I'm going to dive right in. So I'll start with the control plane side of it. So there's really two parts to the Orb system. There's the centralized control plane, and then there's the edge agent that gets deployed into your infrastructure. And for the control tower, it's got several services, right? This central control plane gets installed into Kubernetes, or you can use our SaaS that I'll talk about, but it's responsible for providing the services we see here. First of all, there's a REST API, right? We all want to automate. There's also a portal to help you manage these things we see here. And the first thing is fleet management. So the idea is that we want to be able to work with a range of agents that are out there that are doing this observation. And that means we need to provision them and connect them and organize them and so forth. Next is the policy management. And so this gets to this idea of dynamic orchestration. We want to be able to tell these agents in real time and reprogram them in real time. And so that means we need a way to store the recipes that we plan to send out to them, right? So policy management is built in. Sync management. So once the agents are out there doing their thing, we want to collect that information and put it somewhere. So this is built into our system. It's not a separate step, creating data pipelines. We will collect the metrics and information and telemetry coming back from these agents and send it to a sink, which is essentially the database where you'd like to see it so that you can run your dashboards and use that data. And then there's this configuration management aspect to it, right? So this is something like your Ansible or your Puppet or something where part of the Orb platform is the ability to address your fleet into groups and decide which policies to send to which groups in real time. So here is a quick architecture overview. It's actually pretty busy. I'm sorry about that. Let me just run through it a little bit. The big cloud in the middle is this orb control plane that I've been talking about. As I mentioned, it can be self-hosted, so you can run your own on Kubernetes. We also do have a free SaaS site called orb.live, which you can check out anytime if you'd like. And that's if you don't want to do the self-hosting part. But we see that it does provide the REST API. You can automate against it. The UI connects into this. And then the whole top part represents the agents, right? And the idea is that you want to install these agents as close to the event sources as possible. And we're able to ingest different types of events, which I'll talk about in a few minutes. But that may be from a DNS server, but it may be from a router or a switch. It may be embedded in a VM or a Docker container somewhere. And you want that fleet to connect into the control plane. We have the ability to send policies out to this fleet and collect back the metrics and the logs that result from that. And then we send that out to the sinks. So the actual dashboarding and visualization, that's not part of Orb. We would expect that you have an observability stack that already runs that, and we want to connect to that and let you use your tools to use that data. I'm just going to go through real quick, what this Orb UI looks like to give a bit of flavor for it. So the fleet management has what you'd expect. Here's our list of agents that have connected in. We can see that they're online. We can see which are offline, which may have gone stale. There's a tagging system to organize the agents and be able to address them. You can see what's running on them in real time. Policy management lists these recipes again that we care about. We're telling the agents how to analyze the data, which data we're interested in, which of these needles in the haystack that we're interested in pulling in. Sinks let us define our databases that we want to send to. You can define many sinks. You can decide which data to sync from which agent. So you can have, from the same agent, you can send it to 2 different databases and do some pipeline management that way. And then we decide how to take a policy and send it out to the different groups of agents. And this happens in real time. And individual agents can run concurrent policies, and we can spin them up and down at any time. And again, the dashboarding piece of it, this is a view of Grafana again, where we're watching the results of the metrics from that we've collected. So that's the control plane side of it. And so the other piece of it is the edge piece, right? So what is this tool that sits at the edge and is doing this streaming analysis? So this comes from technology that we built over the years inside of NS1 called PackAdvisor. And its goal is to tap into data streams at the edge, right? And so originally, this was focused around packet capture. We were using it on our nodes to mostly look at the DNS traffic, but also help us understand, the general network traffic going on. But it's a passive system for looking at the data that's flowing by, and it's using these fast streaming algorithms to analyze deeply. And as we'll see in a minute, there's the concept of using packets, and so we can do some deep packet inspection. But there's also other types of information that we can tap into and use the same concepts of analysis and apply it to different types of taps. But the goal is to summarize, is to pull out these insights we care about and kind of leave the raw data that's not interesting for us right now, pull out those interesting summaries that we care about and generate metrics to collect back. And as I mentioned, this can be reprogrammed in real time. Finally, it's been built to scale up and scale down. So this edge agent is meant to be deployed to handle a lot of traffic, and so we can run it, we can kind of scale it horizontally, even on a single node. And we can also scale it down and into embedded systems, right? So we've got one running on a Raspberry Pi, for example, but that also might be a switch or a router or something. It's written in C++, if that's important to anybody, but it is meant to be efficient. So what types of things can we tap into? So I mentioned packet capture is one of the things that we do. DNS tap is another standard that we support, and this is supported by a lot of the big open source DNS servers, similar to packet capture, but we're sucking in all of that, the DNS information and analyzing that in real time. And we've recently added flow data, so SFlow, NetFlow, IPFix, and other taps to come. And so this tap system is built to be modular and to be expandable. So we can have essentially a plug-in system for it that lets us tap into new things in the future. And what kinds of metrics are we generating right now? So it is focused on the metrics that we've needed at NS1 to help us operate the networks over time. But again, this is something that we're expanding. So there's L2, L3 network metrics, DNS, DCP, and flows is what we're focused on so far. Policy resource usage is another one, and that's because as we start pushing policies to the edge, we do care about how many resources we're using, so we need to be able to understand as we're sending these dynamic policies, how much of this edge compute resources are we using? So we generate metrics based on that, a sort of reflection piece. And again, this is a plug-in system, and so we'll be expanding these as we go as well. So here's a diagram of what it looks like inside of PacketVisor to process the data. So essentially, we've got embedded data stream processing. And I know this one's a little busy as well. I'm sorry, I'll try to explain it a bit. But it's trying to show the concept that we can open up multiple inputs on the same agent and handle multiple policies at once as well. And so what we see here are that we've got 3 policies total, represented by these yellow boxes in the middle, but they're attached to 2 inputs. And so we've got two taps open here. One is on packet capture, and we've set that up to look at ETH0 in this example. And on that same agent, we're opening up another tap, which is to look at flow data, right? And it's bound to a port there. And so both of those are waiting for data and processing the data as it comes in. And they were fired up because we'd sent these policies out. And so the first 2 policies are DNS focused. And they both attach to the packet capture input, and they have a particular filter. So part of the configuration of a policy is which filters are we using. And in this case, we're looking at port 53 because we're interested in DNS. But we have 2 different policies hanging off of that. And the first one is it's been told to analyze the network. So that's going to pull things like top IPs and source ports, and again, that L2, L3 layer. And then we also have the DNS handler. But the DNS handler in particular has been configured to only look at DNS packets that are NX domain, right? So this particular policy that we'd sent out is helping us understand NX domain traffic and the associated network metrics, right? And so that will generate a time series specific to that policy off to the right there. And so it's keeping this in memory for up to a couple of minutes, right? There's no actual local data store. It's not writing to a database. It's in memory. And it's the responsibility of the Orb agent to scrape that data out and keep that pipeline flowing back to our central location. And this information is available locally for usage too, right? So there's actually a local REST API that you can write automation against and use this data in real time directly on the node. But the second policy that we have here, it's also attached to the packet capture, and it's generating the same metrics on the DNS side because we have the DNS handler here, but across a different dimension because this filter is on foo.com. And so it's gonna activate a sort of similar dashboard, except it's only gonna be showing top queue names, well, not top queue names in this case because we only have one, but the ports it's using and the result codes and things are going to be focused on this filter we have for foo.com. And so we fired up a very specific policy to help us debug that. And that's going to fire back into and get collected back into the system as well. And then finally, the last one, while all that's happening, we've also got this flow processor happening, which also has a filter. In this example, we've focused in on this one net block, and we're processing flow metrics and generating time series for that. And the idea is that this is all very dynamic. You can spin up these policies in real time to dig into and give you the insights you're looking for. And just to walk you through the viewpoint of PacketVisor as it's sort of flowing across, and again, I'm going to use this DNS use case analysis. But from PacketVisor's point of view, there's just this stream of DNS streaming across. It comes in spikes, right? There's troughs and there's peaks. but there's a lot of information that's packed into the data on the wire that, that is useful for us, right, as operators. And so, again, we want to understand what's being queried, what are the results, are they failing, what are the percentiles of the timings, what's the cardinality of the IPs we're seeing, and a lot of interesting information. And so PacketAdvisor is watching all of these, and it's pulling out that interesting information we care about, and every minute we get a summary of what just happened. And we're getting those summaries regardless of how much traffic is coming in or not, right? So if no traffic is coming in, or very little traffic, we're generating the same metric series. But if we're under attack and there's a lot of traffic coming in, we're also generating the same amount of data, right? So the output is not a function of the amount of input we're seeing, which is a really nice architectural property. We're not putting more pressure on downstream systems in terms of the collection and the analysis. We're able to operate at that same steady pace. And again, all this information that we're collecting is available locally to the node, so we can action on it there, and we collect it in and get that global view as well. So just a couple of tech notes on the agent itself. So it's mostly been designed to run on Linux systems, x86, 64, and ARM. As I mentioned, we've gotten it working on like even a Raspberry Pi. We've started to experiment with it running directly on some routers that support it. We mostly run Docker containers ourselves, but you can run statically linked binaries. Like basically, we want it to be very easy to deploy, right? This is the type of thing that's supposed to live everywhere, so it needs to be easy to deploy and run everywhere. And the agents themselves connect into the Orb control plane over MQTT over TLS. And so all of the metrics and information telemetry it's sending back is encrypted. And for those of you who are processing flow data, this might be an upgrade. I think it's common to shoot flow data over the internet, sort of open UDP. And if you use this solution, you'd be sending it locally to our agent, and we process it at the edge, and then we ship that back over TLS. I mentioned the control plane, so it does run in Kubernetes if you do want to self-host, and there's other ways to run it, right? This is a microservices architecture. If you're familiar with Kubernetes, we do have a Helm chart available to help you do that. If you don't want to self-host, you can try this also at our orb.live SaaS site. And the way we sync data today, we're focused on Prometheus as a sort of de facto standard for a way to push metrics into a time series database. But we've decided to go with OpenTelemetry, which is in progress, some really great work from a lot of different companies that have decided on a standard way to represent metrics and logs and traces, and we're building this into our system. And that's going to allow us to process the data pipelines and to take advantage of supporting a lot of different ways to export into different observability stacks. And we're kind of just beginning. So, we've used a lot of this technology internally at NS1 for quite some time. As I mentioned, it's been about 1.5 years of working on Orb and putting all these pieces together. And so we're looking for use cases, and we're really interested in how everyone's thinking about observability and whether these ideas are interesting. So we're trying to build our community. We know that there's a lot of different ways we could be looking at the data, looking at different inputs, looking at different ways to analyze the data. We've definitely thought about using machine learning in these pipelines, especially at the edge. That could be very interesting. Things like anomaly detection and being able to use that information at the edge to action on that information. And we might be able to, I've talked about small data, but there's nothing to say that we couldn't mix that with this idea but sometimes we do want the highest granularity of things. Like maybe we can use the Orb orchestration platform to decide that across our fleet, we actually want to take a PCAP sample and get that back in centrally so that we can process it in some way, right? And Orb agent groups give us the ability to address our fleet and do things on them. And then, in the future, maybe there's more interesting ways or ways we can make it easier to analyze domain-specific data streams, right, where you can write a little program that's going to process it in some way and generate the metrics that are very interesting to you. And these are ideas, right? So maybe you folks have other ideas as well, and we're certainly interested in talking about that. So I'm going to wind it up. That's most of it. So if you do have a couple of things that you take away from this, Orb is an observability tool. It's designed for distributed edge networks. It uses this small data concept paired with dynamic policy orchestration. The idea is to get these insights directly at the edge, collect the needles directly from the haystack, and integrate with your observability stacks. Again, it's free and open source software, so we hope you try it out. There's a couple of links here. We do have a community site at getorb.io where you can read a bit more about it. Orb.live is this SaaS site. Feel free to sign up for that. It only takes a couple of seconds. There's no credit card or other kind of sign up. Very lightweight way to try it out. And all of our stuff is hosted on GitHub, so feel free to check that out and give us a star if it's something you're interested in. And with that, I'll wind it up. I hope this was an interesting way to end our Tuesdays.
Thank you for your presentation and time again today, Shannon. We are out of time for questions, but we might be able to sneak one in if one of you have one. Okay. Okay, well.
All right.
Thank you.
Thanks very much.